All right, welcome back. So we are in the second video, and we had just talked about when you have segments that intersect outside a circle, you do the external piece times the whole piece of one of the segments is going to equal the external segment times the whole segment of the other segment. Okay, so let us look at what that looks like down here. All right, round to the nearest tenth, assume segments that appear to be tangent are tangent. All right, so again, I have two segments. I have this 3.3 YP, and then I have P to T. And a lot of times, just to kind of remind myself, I will just write this. I'll say it's the external times the whole equals the external times the whole. All right, so when I look at the first one, my external is 3.3. My whole is also 3.3. Anytime you have a tangent segment, the whole and the external are the same. That's going to be equal to, all right, let's look at the other segment. The other segment, the external piece is 2.2. But it's a little bit more interesting to try to figure out, well, what do we say this length is? Okay, this piece here is 2.2 and this piece here is x, and it's common to accidentally go, oh, that's 2.2x. But remember, if you're doing 2.2x, there's multiplication. Really, it's this segment plus this segment. So we want to add these two segments together. It doesn't matter which direction you add them, x plus 2.2 or 2.2 plus x. It's the same either way. Okay. I'm going to do x plus 2.2. Okay, so now we're ready to solve this. The first thing I'm going to do is I'm going to do 3.3 times 3.3, or you could just do 3.3 squared, and that's 10.98. On this side, what I need to make sure I do is I need to distribute that 2.2 to both the x and the other 2.2. So I'm going to end up with 2.2x plus 2.2 times 2.2 is 4.84. All right, so now I'm going to subtract 4.84 on both sides. $10.98 minus 4.84 is 6.14. And that's going to equal just 2.2x. Okay, then the last thing that I need to do is divide both sides by 2.2. 6.14 divided by 2.2 6.14 divided by 2.2 is 279091 equals my x. And we can round that to 3 decimal places. Oops, I forgot to put my decimal. 2.79. If I look at 3 decimal places, 2.790, and then I look 1 right after that and say, oh, yep, I need to round that up. So it's going to be 2.791. Oh, wait, this is to round to the nearest tenth. That means just one place after the decimal. So I just look one place, I see a 7. I look one further, that's a 9. So I do want to round up, so I'm going to say 2.8. 2.8 equals x. Okay, let's do another example. All right, so again, we want to do external times whole equals external times whole. External times whole equals external times whole. I just like to write that down for myself so I don't forget. All right, so when I look at the first one, and it doesn't matter which one you say is the first one, I just tend to go with whichever one's above the other one. My external is 8. The whole is this 8 plus this 8, so my whole thing is 16. That's going to be equal to then I look at the other one. My external is 6 times the whole. The whole is 2x plus 6. Okay, so 8 times 16, my left side is 128. On my right side, I need to distribute that 6. So 6 times 2x is 12x, and 6 times 6 is 36. Get the 12x by itself by subtracting 36 on both sides. 128 minus 36 is 92. That equals 12x. Divide both sides by 12. Oops, these cancel out. These don't cancel out. 92 divided by 12 is a decimal. 7.6 repeating. So if I round that to one place, 7.6, look after it, there's another 6, so that means I need to round that up to 7.7. Equals x. Okay? All right, let's do at least one more. I'm going to look at the next page, at the next set of notes. And here we're going to kind of be mixing things. Okay, notice this time I'm not dealing with a secant or a tangent. I have two chords. And we said at the very beginning of the first set of notes for today that if we have two chords that intersect, we can say that the little pieces that are made, my 2x here and my 3x here, if I multiply those together, 2x times 3x, that's going to be equal to the pieces here, 6 and 5. 6 times 5. So 2x times 3x, 2 times 3 is 6, and x times x is x squared. 6 times 5 is 30. Divide both sides by 6. And x squared equals 5. Oops. 5. Now, I don't want x squared, I want just x, right? So to get rid of this square, I need to square root, which is going to give me a decimal, and that's fine. Nothing wrong with a decimal. My pencil's rolling away. The square root of 5 is x equals 2.23607. This one doesn't tell me what to round to in the direction, so I'm just going to use my standard round to 3 places. So I'd look at 2.236, 3 places after the decimal. Look one after that, and I see a 0, so I don't round up. I leave it at 2.236. So x equals 2.236. Okay, let's look at number 2. Number 2 is a very similar problem. The difference on number 2 is it's missing a little bit of information, but I remember from the last unit, 9A, if I have a diameter that's perpendicular to a chord, I know it's dividing this chord and the arc into 2 equal pieces. So both of these are x and x. That's going to be equal to, then I look at the other one, I've got 2, and it's tempting to say 7, but remember, 7 is just the radius. If the radius is 7, and I've already gone 2, then left here is 5, so this whole segment then is really 7 plus 5, which is 12. Okay, so we end up with x times x, which is x squared, equals 2 times 12, which is 24, and then I have to square root. And I'm going to get that x equals the square root of 24. The square root of 24 is 4.89898. I believe it's repeating. It looks like it. It doesn't tell me what to round to, so again, I'm going to go to the old standby, go to 3 places after the decimal. 898. Look one more and say, oh, that's a 9, so I'm going to round up. So 4.899. X equals 4.899. Okay? We'll stop there looking at those chords, and we'll pick up with our external times whole equals external times whole in the next video, looking at more of those examples. All right, so I'll see you back in the next video.